Here we go. How to develop Sam's streaming service from scratch. I'm not going to use the to-do. I'm going to figure it out myself. We want to create a file. Streaming service.py. There. So all together now, we have price tiers. And it says allow the user to choose again or not. And pretty much that's what it says. And it shows a little to do. And we want to be able to do is determine what your price is. Anything we know before the program starts, which this we know before the program starts, 14 years or older is $12.95. 4 years and below 14 is $10.95. So these two would be put in as constants because we know exactly what they are before the program starts. And you can't start a variable or constant name with a number. So one way we might do it is to do 14. Maybe just do 14. And then we put in 12.95. Oh, my numlock got turned off, 12.95. So now I've assigned that price to this constant. Next year, when Sam raises his prices, I don't have to go through the whole program. I just have to go up here, change that to 13, and it changes everywhere it's being used in the program. That's the purpose of a constant. The other constant we need is 4. So I'll just put 4. I could have put 4 years. Well, maybe I will put 4 years. That's a better description, isn't it? And that is going to be assigned 10.95. So since I did that, I will do 14 years. So we start at the top with anything we know before the program starts. If we just type 12.95 in the middle of our program, that's what's called a magic number, meaning it has no meaning. Why is there a 12.95 in there? What does it mean? And when we're writing code, we want the code to have meaning itself. And if there isn't enough meaning in the code, then what we do is we put a comment in it. Like in this case, 14 years, 4 years isn't really very descriptive. So I might say something like price, tiers, yeah, per age. You know, greater than 14 and greater than 4. So I just made some notes to somebody coming in my program after it's been sitting for a year and after it's been running in production. And Sam says, oh, I need to charge more money. Can you make that change? Well, I can. He says, make some changes to the price tiers. So now I've commented it, I put it in, we know it ahead of time, we're good to go. Next step, in our programs, we have 3 major pieces. Input, calculation, output. Those are our 3 big pieces we'll always have. The input may not be from the keyboard, but there'll always be something coming in. Even if it's hard-coded, that's still input. So we need to get the age from the user, right? Because we want to know how much to charge them for the streaming service. You could determine, do you want to just get whole numbers? I think that makes sense. Because if they're over 14, we don't want, oh, they're 14 and a half, they're 13 and 3/4. We don't really care. Could you do a float? Yes, perfectly fine. So get the age from the user. So I'm going to use age as my input variable. And we know that input allows us to get input from the user, and it comes in as a string. So what is your age? I am leaving out the part where you put in the pretty little title that says Sam's streaming service. This is where you go to get all your TV. I'm leaving that out. Now it's coming in as a string. We want to convert or cast is the programming term. to an integer data type. So in programming, in Python, primarily we'll use three data types: strings, integers, floats. Integers are whole numbers. Floats are anything with a decimal point. Those are the three main ones we'll use. In fact, in most programming languages, that's pretty much what you use. There may be differing degrees of precision for the floats, but we will get to Booleans and some other stuff, but these are the three big ones. So now I've gotten the age. It says, oh, allow the user to choose to run again or not. So we need a loop, don't we? Well, do we need a loop? Where do we need our loop? I kind of put this in there backwards, didn't I? Well, I didn't. Because the loop should go around all of our stuff. So I'm going to do a while true, which is perfectly fine for a menu loop. In fact, I'll refer to a while loop sometimes as a menu loop. A while loop will keep going until the user gives a reason to terminate it. It's what's called an indefinite loop, meaning if there isn't a termination condition, it'll go forever. So we use while loops when we don't know how many times we're going to loop. We use for loops when we know how many times we're going to go through the loop, typically. So we get the age from the user. Now it says price tiers per age. What in the world do we do here? So if the age is, oh, I did that backwards. The age is greater than 4 years, we do something. Now, one of the other reasons for constants is it helps create what might be called self-documenting code. If you name your variables well, you name your constants well, that doesn't mean you shouldn't comment, but it makes the code easier to read. Oh, and Sean asked me this the other day, and I'm going to explain it the next time I use it. There's a concept in coding called clean code. Clean code looks neat. It's always indented the same. It looks pretty. It's easy to read. It's very concise. So clean code is a thing in programming. It just means that it looks very nice. It's easy to read. I can follow the logic of it very well. Requirements of a program set up the parameters and how you're supposed to create the program. So that's right. So we want greater than or equal to, because that does say 14 years old and older. Very good. So if the age is 14 years or older, we're in trouble now. We're supposed to find out, I think we're supposed to say how much money, aren't we? Oh, your monthly fee will be your monthly fee. Well, we don't have a monthly fee, do we?
Am I missing something? Why are you comparing age to the money?
The tier,
The tier.
the monthly.
We have 3 price tiers for our streaming service.
Right, but you're comparing price to age.
No, age. I type in 15. I'm in the top tier. I pay $12.95 a month. If I type in 13, I pay $10.95 a month.
Right, but 14 years in the constant form right there is the price. No?
Oh, you're right. Oh, and you're way too smart. So is Eliza. Okay, well, the class is way too smart for me. So this is the tier 1 is $12.95. Tier 2. Tier 2 is $10.95. We do differentiate it by age, as Owen pointed out. So Owen and Eliza are like keeping me on track here. Whew, that's not how you develop a program, by doing dumb things like that. All right, so if the age is greater than or equal to 14, that work? Oh, I misspelled it. That's why it is making me. There. Will that work? Now, where people will get confused in making decisions is once you have eliminated 14 and above, you never have to test for that again. So one way to do this is you can do LF age is less than or equal to 14 and then do ands and ors. But do we ever have to test for it that it's above 14 again? If we do LF age is greater than or equal to, what is it, 4? Yeah, 4. It does say between 4 and 14, but isn't all that's left 4 to 14? And between 4 and 14, so we've already eliminated 14 and above. All that's left is 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, if I wanted to include 4, which I wasn't very, that would be something where you may have to call up the customer. Do you want to include 4 or, you know? Anyway, we'll just assume that it's that. Do we need to test to see that the age is under 14 at this point? It's less complex. So if they're greater than or equal to 4, we have eliminated 14 already. We know that they're going to be in tier 2. Now, else, oh, forgot to do price. Otherwise, what's the cost? It's free. That's it. Now, the last requirement is allow the chooser to run again or not. I'm going to do it by having them type Y to continue. So I will call it, boy, what should I call it? Menu choice? Because we have to store it and we have to make a decision. Because the computer can't look at my keyboard and say, oh, he said yes, let's keep going around. We have to store that information in a variable, then we have to compare that variable with something else. And we can compare strings, we can compare integers, you really can't compare floats. Well, you can compare greater than or less than, but you can't really compare equal to. Continue. Or you could say, do you want to calculate another one or something like that, whatever you want. And I might do this, so they know that if they type N, they're going to exit. You're prompting the user in such a way that they know what is coming up next. And I don't know if that's how I did it on the other one or not, but it doesn't matter. Does that make sense? Something like that. You could say, do you want to continue? Do you want to do another calculation? Now, how do we determine whether we continue or not? How do we determine if we're going to continue the loop or not? When you're comparing strings, it always has to have quotes around it. How do we get out of a loop?
But if you're continuing with the Y, would you want to break it?
Uh-oh. What do we do if we say Y to continue? Then how do we do that? How do we break if it's not Y?
But continuing.
That seems like something, like.
Yes, exactly. So if menu choice is not equal to.
Yeah, that's what I'll see.
Yeah, no, that's right. That's one way to do it. On was wanting to do continue, which would be fine, but then how do we get out of the loop? Continue means that we jump past anything that's happening in the loop, and then we go back to the beginning.
Do it else. Then break.
Oh, yeah, that would work too. Let's do what Owen said. I hadn't thought of that. So if you do yes, continue, which that's a good one to put in here. Continue is a keyword that means, okay, from this point, we're gonna jump to the beginning of the loop. We're gonna skip anything else that's below it. I hadn't thought of doing it that way. Else, break. That's another way to do it. Or the way Eliza did it, does it in 2 lines. That would work also. Either one. We just want to make sure that if they do not type a Y, we're out of that program. Now, what if some silly person types in a capital Y? What's going to happen? Are we going to exit the program?
Should do it. Should do it.
No, it shouldn't, and it won't. Fortunately, we have something we've not done anything with. There's a method that will allow us to convert a text to lowercase. All right, so our text is menu choice. It could be uppercase, it could be lowercase. If someone types in uppercase, which some people insist on typing capitals, even though it's a lowercase, when you're doing a menu system, you typically want to do, we don't care what the case is. And one way to fix that is to convert it to lowercase. So we can do menu choice dot lower. That converts. It returns a copy of the string converted to lowercase. Which does mean we have to assign the result of that. It's a calculation. Menu.lower is changing it, it's calculating. We have to assign that to another variable, which we can just assign it to itself. That's perfectly fine. So now menu choice will be in lowercase. Whatever the user types in will be in lowercase. And then we can compare apples and apples. Another way to do that would also be if you equals this, or, you know, there's other ways to do it, but this way you end up with the same thing that you're comparing. You're ending up with lowercase y. That's an addition. It's just part of our conversation here we're having, because we could also do Eliza's method where we have not equal to. We can do Owen's method where he's going to continue. And if they don't type a Y, then he breaks. Both of those are valid choices. Now the big question is, does it work? I kind of forgot to test my program again as I was working on it. Uh-oh. What am I missing here?
Your print statements.
Yes. Whoops. Print. We'll just print the price. Because you can't echo the age and all that stuff, but I'm just gonna print the price. Oh, I can't see what that thing's showing up there. There we go. Doesn't have to be perfect right now. You can make it beautiful later on. I'm 3, 2, 0. Continue. Say 5. All right, so far so good. All right. And you do know that we're not actually testing for n. But by indicating an Y and a no, we're indicating that yes continues and no exits, right? You were inferring it by as part of the interface design. Good interface design leads the user to do things without having to explain things. It's like a good movie. Doesn't have 5 minutes of explaining what the movie's going to be about. You always know it's going to be a cheesy movie when they go on forever about, well, this is set in the blah, 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 blah. No, good movies just start right out and they go. However, Star Wars, yeah, it started out with the whole rolling credits thing. Yeah, we can make an exception there. Or you might consider that that's not a great movie, but yes. It should be implied by context. So interface design is. So one of the students said, oh, you should do it like this. And they're right. This is how you see these sorts of things. Yes, no. If you type in, we don't care. You could type LZ, X, or Y, it's still gonna kick us out because it's not Y. Does the user need to know that? No. They don't need to know that. Ta-da. And yeah, you want to try to design your interface to be intuitive. So people can figure out what to do by looking at it and not having to have a whole prologue of explaining what you're going to do. And interface design is a whole field of study.